So, let's go. Number 1, the previous universe left marks in our sky. Look up. Not tonight, not with your eyes. Look up the way a telescope does at the faint background glow that fills every direction of the sky. That glow is the oldest light there is. It has been traveling toward you for almost 14 billion years, and for a while a small group of physicists thought they could see something hiding in it. Something that shouldn't be there. Faint rings, circular smudges pressed into the light like fingerprints in wet paint. And they had an idea about what made them. The idea belongs to Roger Penrose, and it is one of the strangest, most beautiful theories anyone has ever taken seriously. He calls it conformal cyclic cosmology. Here's the pitch. Your universe is not a one-time event. It's one link in an endless chain. Penrose calls each link an eon. Ours is just the current one. Now follow this, because it's the part that breaks people. Run your universe all the way forward. Every star burns out. Every galaxy goes dark. Every black hole slowly evaporates, hisses itself away into nothing, over a span of time so long you can't hold it in your head. What's left at the end is cold, empty, and endless. Just light, drifting forever. And here's Penrose's trick. In a universe with nothing left but light, there's no way to measure size, nothing to hold a ruler up to, nothing to hold a clock up to. So the cold, dead, infinitely stretched out end of one universe looks mathematically identical to the hot, dense, screaming birth of the next one. The end becomes the beginning, not as a metaphor, as geometry, which means the Big Bang wasn't the start, it was a handoff. And if that's true, then the universe that came before ours might have left something behind. That's what those rings were supposed to be. Penrose and his colleagues said they were the leftover echoes of supermassive black holes that lived and died and evaporated in the previous universe. Their final energy, bleeding through the seam between one cosmos and the next. They called them Hawking Points, little tombstones from a world that ended before ours began. It's a gorgeous story. You are looking at the ashes of the universe before yours, and then everyone else went and checked. In 2020, another group ran the numbers and found that the rings were exactly what you'd expect from random noise, once you account for the fact that if you look at a big enough sky, you'll find patterns anywhere. Look hard enough at static and you'll see faces. In 2023, a study using machine learning found nothing. In 2024, another reanalysis, same result. The tombstones faded. So maybe the previous universe didn't sign its name in our sky after all. Or maybe it did and we just can't read the handwriting yet. Either way, keep that seam in mind. The idea that an ending and a beginning can be the same instant. Because it's about to get worse. Number 2, everything that exists was crushed, then bounced. Forget the explosion. You've been sold the Big Bang your whole life as a bang, a burst, something appearing out of a single point. But there's a whole camp of physicists who think the point never existed at all. Their version goes like this. Rewind your universe, everything rushes back together, galaxies fall inward, then stars, then atoms, all of it collapsing toward a single unbearable density. In the old picture, this is where physics dies. Everything crushes down to a point of infinite density, a singularity, where the math just throws up its hands and stops working. But what if it doesn't crush all the way down? This is loop quantum cosmology, and it starts from one radical idea. Space is not smooth. Space is not an infinitely divisible sheet you can keep cutting forever. Space comes in tiny, indivisible chunks, little grains. And when you try to squeeze the whole universe down past a certain point, those grains push back. They refuse to be crushed. The harder you press, the harder they shove. So instead of collapsing into a point, the universe hits a wall and rebounds. A bounce. And they can tell you exactly how dense it gets before it snaps back. Right around 40% of the densest state that physics allows. That's a number so large it's almost comedy. Imagine cramming the mass of a trillion suns into the space of a single atom, and then imagine that's not even the maximum. That's the floor the universe bounces off of. Which means the thing that came before your Big Bang was another universe, an older one. And it wasn't being born. It was dying. Sit with that. Somewhere on the other side of the bounce, there was a cosmos falling in on itself, its sky compressing, its galaxies streaming together. Everything that had ever existed in that universe, every world, every possible history, getting funneled down into one final catastrophic squeeze, and in the last instant, the grains of space pushed back. And all of it came screaming out the other side. As you, as this, as everything you'll ever see. Your beginning was somebody's ending, and the only thing separating you from that dead universe is the thinnest moment there has ever been. We're 2 theories in, and both of them say your universe had a parent. Now let's try the opposite. Let's try no parent at all. Number 3. The universe tunneled out of absolute nothing. In 1982, a physicist named Alexander Vilenkin published a short paper with a title that sounds like a threat. Creation of universes from nothing. And he did not mean nothing the way you mean it. When you say nothing, you're picturing empty space. A dark, quiet room with no furniture, but that room is still something. It has space, it has volume, it has a here and a there. Vilenkin meant something so much emptier than that. No space, no time, no room at all, not even the darkness. Take the room, take the walls, take the emptiness inside the walls, and take that away too. That is what the universe came from. And the way it got out is the part that should keep you up. It tunneled. You've maybe heard of quantum tunneling. It's a real thing that real particles do. A particle can pass through a barrier it has no business getting through, appear on the other side of a wall it never had the energy to climb. It just shows up where it shouldn't be. The universe, in fact, runs on this. The sun shines because of it. Vilenkin looked at that and asked the question you're not supposed to ask. What if the whole universe did it? What if reality itself tunneled, not from one place to another, but from no place at all, into being? There's no explosion in this story, no point that blows up. There's a nothing so complete it doesn't even have a location, and then, through a quirk of quantum math, a tiny universe simply is. And once it exists, it inflates faster than you can imagine into everything. Notice what's missing here. There's no cause, nothing pushed the button, nothing decided, nothing was there to decide. The universe didn't come from something. It didn't even come from nothing, not really, because come from is a phrase that needs a before, and there was no before. There was only the tunnel, and then this side of it. You want to know what existed before time. Vilenkin's answer is the most honest and the most disturbing one on this whole list. Nothing existed before time, and nothing is exactly what it took. But hold on. If you make an entire universe out of absolute nothing, doesn't that break a rule? You can't just conjure 1 trillion galaxies for free. Or can you? Number 4. It costs nothing to make everything. Here's the objection your gut is making right now. Everything costs something. You can't get a cup of coffee for free, let alone a cosmos. Energy doesn't just appear. It's the one rule the universe seems to actually enforce. So how do you build all of this, every star, every planet, every atom in your own body, out of nothing without paying for it? The answer is one of the sneakiest ideas in all of physics, and once you see it, you can't unsee it. You get it for free because the total bill comes to 0. Think about the universe as a bank account. On one side, you've got all the positive energy, all the matter, everything with mass, and mass is just frozen energy. That's what the famous equation means. Add up every star and galaxy and dust grain, and it's a staggering, unthinkable pile of positive energy. But there's another side to the account. Gravity. And gravity, it turns out, counts as negative energy every time 2 things pull on each other. Every time anything is bound to anything else by gravity, that's energy in the red. It's a debt. And the universe is absolutely full of gravity. Every galaxy, every cluster, every bit of it, pulling on every other bit. Now here's the punchline. When you add it all up, the enormous pile of positive matter energy and the enormous debt of negative gravity energy may cancel. Exactly. The books balance. The total energy of the entire universe might be precisely 0. The physicist Alan Guth called it the ultimate free lunch. And it means creating a universe from nothing doesn't break the one rule you thought it broke. Because you didn't actually make any net energy. You made a giant positive number and an equally giant negative number at the same instant, and their sum is nothing at all. Let that reframe everything you just heard. The universe might not be a thing that was added to the void. It might be the void, split into a plus and a minus, pretending to be something. The most complicated way of writing zero that has ever existed. You, your whole life, every person you've ever loved, every light in the night sky. A rounding error that adds up to nothing. Which raises a much worse question. If everything nets out to nothing, and there's no before, then what were we even measuring time against? Maybe the problem isn't what came before time. Maybe the problem is time itself. Number 5. Time is just heat. Pretending to flow. Stop for a second and actually try to find time. Not a clock. A clock is just a thing that moves. I mean the flow. The sense that right now is sliding forward, that the past is behind you, and the future is coming. Where is that, actually? What is it made of? Because there's a theory that says it isn't made of anything, that time isn't a fundamental piece of reality at all, that the flow you feel so certain about is a side effect. A rumor. A trick that heat plays on you. This is the thermal time hypothesis, and it came from two physicists, Alain Connet and Carlo Rovelli, back in 1994. And their claim is quietly one of the most unsettling things anyone has said about your daily experience. What you feel as the passage of time, they say, is really just thermodynamics. It's heat. It's the way warm things spread out into cold things. It's entropy, the universe slowly shuffling from order into mess. That, and only that, is what later means. Here's how to feel it. Why does time have a direction? Why can't you unscramble an egg or unspill a coffee or get younger? You've never seen heat flow from cold to hot on its own. It always goes one way, warm bleeding into cool, and that one-way street is the arrow you call time. Connet and Rovelli flipped it around. They said the arrow isn't following time. The arrow is time. There is no separate river flowing underneath. There's just heat spreading out, and you calling that the future. Now take that idea and point it back at your question. What existed before time? If time is just heat pretending to flow, then before time isn't a dark, quiet waiting room. It's a state where there is no flow at all. Things could be there. Stuff could exist. But nothing happens because happens needs a before and an after. And without heat spreading out, there is no before and after. It's a where with no when. A frozen everything that isn't waiting for anything. Because waiting is a thing that takes time, and there isn't any. You've spent your whole life inside a current. Sure, it was carrying you somewhere. This theory says the current was never real. You're not moving through time. You're just getting warmer in a very particular direction. Number 6. Before space, there was a frozen tangle of strings. Everything you've been picturing so far has been about size and density. Squeeze the universe down, crush it into a point, tunnel it out of nothing. But there's a version of the beginning that's about temperature, and it hides a wall you didn't know existed. You know you can't get colder than absolute zero. That's the floor. Motion stops, and there's nowhere left to go down. Fine. But here's the thing. Almost nobody tells you. There might be a ceiling too. A hottest possible temperature. A point past which hotter stops meaning anything at all. This is where string theory has something to say about the beginning. Two physicists, Robert Brandenburger and Kumrun Vafa, imagined the very early universe not as a point, but as a small, dense, unbelievably hot gas. Not a gas of particles, a gas of strings. Tiny vibrating threads, the stuff everything is supposedly made of at the deepest level, packed together and screaming with heat. And this gas has a limit. It's called the Hagedorn temperature, and it's the hottest anything can get. Here's why. Normally, when you pump energy into something, it gets hotter. You heat the pan's temperature climbs. But pour energy into this string gas, and something bizarre happens. It doesn't get hotter, it just makes more strings. The energy goes into creating new stuff instead of raising the temperature. The thermometer just stops. And this ceiling is real enough that physicists have a rough number for it. Around 1% of the absolute maximum temperature the universe could theoretically hold, which is still hotter than the center of the sun by a factor so large it barely means anything, 100 trillion times hotter, give or take. And that's the wall. So picture the beginning like this. Not a bang. Not a point. A tiny knot of strings sitting exactly at the hottest temperature that can possibly exist, unable to get any hotter no matter what you do. And because it can't get hotter, it doesn't rush anywhere. It just hangs there. Still. Near eternal. A frozen tangle at the edge of what heat can do, waiting, if you can call it waiting, to finally begin expanding into space. That's the before this theory offers you. Not empty, not nothing. A single humming, impossibly hot knot that has nowhere hotter to go. It's strange to think that the universe might have started at its absolute limit and cooled down from there ever since. That the beginning wasn't the smallest, simplest thing. It was the most extreme. And everything since, including you, has just been the long slide down. Number 7. The first thing was a single quantum. Every wild theory you've heard tonight is standing on the shoulders of one man, and you've probably never heard his name. His name was Georges Lemaître. He was a physicist. He was also a Catholic priest, which is going to matter in a second. And in 1931, he wrote a short letter to a science journal that basically invented the idea you now take for granted, that the universe had a beginning. Before Lemaître, most scientists, including Einstein, assumed the universe was eternal, static. It had always been here and always would be. No start, no birth. It just was forever in every direction, backward through all of time. Comfortable, tidy. And, Lemaître thought, wrong. His logic was almost childishly simple, which is what makes it powerful. The universe is expanding, everything is flying apart. So play the movie backward. If things are getting farther apart now, then yesterday they were closer. And 1 billion years ago, closer still. Keep rewinding, and everything you can see gets squeezed together, tighter and tighter, until all of it, every galaxy, every star, every atom in your body, is packed into a single object. He called it the primeval atom. The cosmic egg. One dense speck containing all of reality, unstable, ready to break apart. And when it broke, when that single quantum disintegrated, that shattering was the beginning. Of space. Of time. Of everything. Now, the priest part. When Lemaître explained his idea to Einstein, Einstein didn't like it. And what he said is one of the great quotes in the history of science. He looked at this priest proposing that the universe had a birthday and he said, "No, not that. It smells too much of creation." Einstein wasn't objecting to the math. The math was fine. He was objecting to how much it sounded like a beginning. Like a first moment. Like a thing a universe is not supposed to have. And the beautiful irony is that Lemaître, the one man in the room who actually had religious reasons to want a creation, was the one insisting on keeping his science and his faith in separate rooms. He wasn't trying to prove anything holy. He was just following the numbers back to their terrible edge. And that edge is exactly the thing we still can't get past. Lemaître ran the movie backward until everything became one point, and then the film ran out. What happens in the frame before the first frame? He gave us the whole idea of a beginning. He just couldn't tell us what it was a beginning out of. Nobody could. And when you push right up against that first instant, physics itself starts to come apart. Number 8. Reality began as boiling foam. Let's actually go there, to the first moment, as close to the beginning as physics can crawl before it starts screaming. There's a specific number for how close we can get. It's called the Planck time, and it is the smallest slice of time that has any meaning at all. Write it out, and it's a decimal point followed by more than 40 zeros before you get to a single digit. It is so short that everything, all of history, all of science, all of your life happens in the vast, comfortable afterward. The Planck time is the first tick. And here's the horror. We cannot see past it. Not because our telescopes aren't good enough, because before it, our physics simply does not work. The equations return nonsense. The map just ends. But we can guess at what's there. And the guess is called quantum foam. Down at this scale, everything you believe about space is a lie. You think space is smooth, flat, a calm, empty stage that things happen on. It isn't. zoom in far enough past atoms, past the particles inside atoms, all the way down to the Planck scale, and that smooth stage dissolves into chaos. It boils. It froths. Space itself is tearing and reconnecting, bubbling with tiny black holes that flash into existence and vanish before the word exist even finishes. A churning, violent foam where up and down and here and there stop being reliable words. And now the part that should genuinely unsettle you. In that foam, cause and effect don't work. You live your whole life on cause and effect. This happens, so that happens. You drop the glass, it breaks. First one thing, then the next. That order, that chain is the deepest thing you know. And in the quantum foam, before space and time smoothed out into something stable, that chain doesn't exist. Things aren't happening in an order because there is no order yet. There's no first, no next, just the foam, boiling, without before, without after. One idea is that time only switched on when one direction pulled itself out of that chaos and became forward. Like the foam settling, and a single arrow finally pointing one way, and only then, in that instant, does cause and effect begin. Only then does the Big Bang have a next. Before that, there's no story to tell because a story needs one thing to follow another, and nothing follows anything in the foam. So this is the last real thing science can offer you. A boiling sea with no floor and no clock. And past it, where every one of these theories has been quietly pointing the whole time, there's a question we might not even be allowed to ask. Number 9. There was no before. And that's the worst answer. Here's the theory that ends the tour, and it doesn't give you a stranger, spookier version of before. It takes the word before away from you entirely. In 2003, 3 physicists, Arvind Borde, Alan Guth, and Alexander Vilenkin, proved something. Not guessed, proved as a piece of mathematics. And what they proved is this. Any universe that has, on average, been expanding throughout its history cannot stretch back forever. It has to have an edge, a past boundary, a first moment beyond which the timeline does not continue. And it's ruthless. This isn't just about our universe. Their result cuts through the fancy escape hatches too. The eternal inflation ideas. A lot of the multiverse pictures where universes bubble off forever. Even most of those, the math says, still have to start somewhere. You can run time forward forever, but backwards, sooner or later, you hit a wall, and there is no going through it. So you ask the natural question, fine, what's on the other side of the wall? What came before the first moment? And the answer, the real answer, is that the question is broken. You know the trick with this one. You've heard it before. Ask what's north of the North Pole. Go on, stand at the North Pole and point north. You can't. There's no such direction. It's not that the answer is hidden or far away or too weird to understand. It's that north of the North Pole is a string of words that doesn't describe anything. The pole is where north runs out. That might be what before the beginning is, not a dark room, not a void, not a previous universe or a frozen string or a boiling foam, just the place where the word before runs out. Time starts here, and asking what came earlier is like walking off the edge of a map and being surprised there's no more map, and here's the twist that makes even the experts squirm. The 3 people who prove this don't agree on what it means. Vilenkin thinks it shows the universe truly began. Guth, who helped prove the very same theorem, thinks the universe had no beginning at all. And other physicists think the whole thing dissolves the moment you have a real theory of quantum gravity. The people who found the wall are standing right next to it, arguing about whether it's really there. Which leaves you exactly where every one of these theories has been leading you. Not with an answer. With a question that quietly deletes itself the moment you ask it. You wanted to know what existed before time. And the most honest thing the universe has to say back is that before might be a door you painted onto a solid wall. You can knock on it as long as you like. There was never a room behind it. There was never a behind at all. And the strangest part, the part you'll lie awake on, is that this emptiness, this no answer, is the one thing about the beginning that might actually be true.